everybody. Papa Bale, welcome to the channel. We're live, and we've got our dual drive hooked up currently. I was really wanting to get out my signal generator and hook up this Litz wire coil via transistor M.P.H to the signal generator and pump up the frequency and see what we could get. But that'll take some remodeling. So I think, and we could start this up, the dual drive. We're going to turn it down though, from 6, since we're not really focusing on generating right now, just on having some entertainment, I guess. We'll go 3. That's good. All right, cool. Now that's maglev. We're going to turn it all the way down to 3 volts. And that's pretty neat. Okay. We might do a few different coils. Take the shaft out. Gotta get my aluminum board. So I'm gonna grab that. Nice flat surface. That's 3 volts in, man. I mean, the generation isn't gonna be that great at 3 volts, but look at the amount of mechanical energy we get with the dual drive.
Mm-hmm.
So if I were to hook up an AC alternator coil, it would generate quite a bit more AC than if it were going slower, you know? Kind of common sense application. What just happened? Okay.
Hey everybody, welcome to the channel. Thank you for dropping in.
Hello, hello.
This is Papa Bale. We're working with pulse motor experiments today.
So we got a Litz wire coil. It's got to be 20 turns, maybe more. It's an 18 gauge. It's 100 strands of 38. So, but it adds up to an 18 gauge. I don't know exactly how many turns it is. It's got to be between 35 and 20. 20 and 35. Whatever way you want to do it, I don't know. Alright, so Then the next day or so, I'm going to test all these transistors, and the ones that don't work go into the heap.
To the heap. Hey, welcome in. Thank you for dropping by.
Hey, what's up? All right, sweet. So this is a signal generator. And we're going to hook the multimeter that has the oscilloscope up to this apparatus. This whole setup over here is going to have that meter.
Welcome in, Elias.
Hello. Saturday, great day.
It's going to be hot tomorrow.
Very hot. Okay, so this, we'll get a transistor for it. Cool. All right. It is the right one. If I could just remember what I'm doing here. We're shutting this down. If we're setting this one up, we gotta shut this one down. Because we're gonna split it now. Unless we wanna run that on a battery. Yeah, we could do that. We'll shut this one down anyway, since we're focusing now on the signal generation. We're gonna do 2 tests for each coil at several different frequencies. We're going to do the green paper test, and we're going to do the iron filing test. Alright. If we're going to use the battery, we got to have a toggle. I'm not seeing offhand any of my toggles. You see an on-off switch anywhere?
I'm looking.
You know what you're looking for? Yeah?
Yeah, like the black switch.
Maybe, I see one right now. Okay, that's good. We got it.
Mm-hmm.
We'll use this battery. You know what? I want to use a power supply because you got a lot of control with the power supply. So what I want to do, I still need the the on-off thing, because I'm gonna hook up the battery and turn it off. Huh. It's all right. This is what we're doing. So we'll just unhook those connections. That's okay. 'Cause this is coming too.
You said you can make a Peltier module air conditioner.
Nice.
Hook to one of those. We'll look at that.
All right.
Thank you for the like. We are working with pulse motors today. And we are hooking up, that's a signal amplifier.
What?
This machine right here.
This is a signal generator.
Generator.
Yeah. So we're going to send an arbitrary waveform through that Litz wire coil right there.
Yes. Appreciate you. Welcome in, Hamid.
And we're gonna get an oscilloscope reading, a multimeter reading for voltage, and then we're gonna get green paper reading, magnetic green paper reading, and iron filing reading. So like we're gonna see if we get any of that iron dust to form on the coil. As soon as we get it hooked up. All right. So, and it's not that there's like a lot of stuff, it's just this little stuff. There we go, we got it.
Welcome, Alexa.
Hello, hello. So we're just going to start basic positive end of the power supply where it goes. And it goes to the collector. Of the NPN. Which should be BCE. It's not BCE, you should adjust it because this is for BCE. Base collector emitter. Not order from left to right. So if we refer to it again, it's BCE. Okay. And then we're going to go from the emitter yeah, don't sit down.
Mm-hmm. Wholesale cleaning with this setup. Welcome in, Muhammad.
All right, so now we've clipped not all of the strands are contacting the clip, but all the strands are contacting the clip through contacting each other. So I would consider that to be a good connection. Good enough. For what we're like trying to get out of this, that's good enough. I believe that. All right. Now we're going to take the end of the coil now you really want to try and get all the strands in there though. They don't want to be bent back. You want to have them all in the clip. There we go. So this is going to go to the negative of the power supply. And there's your basic drive loop. It goes power supply, transistor, coil, back to the power. Now, for any of the standard transistor connections, okay, I see it. We want to go collector to emitter with some form of light bulb that has a filament in it. I use a halogen bulb. A lot of people use neon bulbs. I use neon bulbs. But I think that this will have the same effect. It's a 120 volt neon bulb or halogen bulb.
And what does having the bulb in there show you? Do for you?
Well, I'm not exactly sure all of what it does, but it smooths out. It takes excess energy from the circuit, and it I think it's an oscillation circuit, so it just kind of loops it.
And then the bulb lights up, and
yeah, the bulb lights up. It gets really, I mean, like if we put it up to 24, it'll get really hot.
I gotcha.
All right, so now we got to hook up the signal generator, and I think you can control all that based on the frequency, like how hot it will get.
Hey everybody, welcome to the channel. Thank you for dropping in. We're building a circuit right now. Let us know if you have any questions.
So we're going to hook up the base to the signal generator, and we're going to hook up the negative of the signal generator to the emitter, and it's going to ground. All right, so let's see what happens here. Nice. So we're going to get an indicator. This nice spherical magnet. We're going to put that right there. Now where do we put these to get the good reading on this circuit? We hook it to the coil. What are we trying to read exactly, if there's any energy coming out of it? I'm on an oscilloscope reading, so I think I'm going to hook it to the coil. Just never quite know on when you switch up a circuit. Or when I switch up a circuit, I should say.
Thank you for the likes.
Yeah. All right, so all right, I don't know if that's good. You know, I don't know if that's gonna work. Maybe we'll just leave it out for now. Unless we can clip it on the very end here and have it mean something, then it's good. We'll see in just a minute.
Thank you for the like.
Okay, so we clip it to the negative. So we got some motion out of that. That was 10 kilohertz though. We did get motion, yeah? Yeah, it's sucking on it.
Mm-hmm.
All right, let's turn that down. Frequency.
How's it going, Beat? Welcome in.
Hey, Beat. We'll go down here to 1.
Welcome in, DIY. Thank you for the like. Have you, okay, Andy.
All right, so at really low frequency, it like sucks a lot of amperage out. So let's turn it up. Since it's a Litz wire coil, let's start at 100. Wow, that's awesome. Now let me look here at the voltage, DC voltage. Not much, like 300. Let's try changing it to AC since we're reading the coil. Nice. But we don't have a receiver coil. What do we want to use as receiver coil? This one right here, this will work. Right. Now, think. That like that. Then we'll hook the multimeter up to the receiver coil. And we'll get, I think we're going to get a nice reading, and then we can even change around, make the Litz wire the receiver coil. But yeah, let me switch around.
Yeah, Litz has very many thin wires. I'm gonna try to close up on that.
Right now we're using it as the frequency generator. We'll see what reading we get. Here we go. 100 hertz. Or is it 1,000 hertz? 16 volts AC on 3 volts in DC. But it's very high on the amp draw. Oh wow, that's okay. And we just add a little bit of.
No shit.
So 200, 200, and then we're gonna go to the. Wow. Okay. 210 is 107, dude. So now we're gonna go to the single, to the hertz. There it is, 114.2. at 213 hertz. It seems to be at this level of frequency, the coil's max output.
Okay.
But I believe there are different plateaus. So like if I go up to like 10,000, let's try it. So we got 45 millivolts. Okay, so we're not getting much generation. And that was a lot less draw, though. A lot less amp draw. So 1,000, or was that 1,000? Yeah, 1,000. Wow. 7.2.
And DIY Andy says, you should see how my home looks like now. I told my wife, she said we may make a good team. People should know they live with this thing at home. They don't understand the DIY stuff.
Oh, they don't? Yeah. I don't know. I don't know. But I think that's pretty good. We're not getting the same amount though that we just got. Previously, we're getting a little less at the same frequency. So, go figure. Must have bumped into it or something. But let's change the wave. Let's do that. We got a sine wave now. And a square wave. Wow, man, the difference in energy is amazing. So you get, with a square wave, you get like 90 less AC.
One more time.
The pulse is the same as a square. That one's pretty good. What is that?
See you later.
See ya. Triangle. Wow. Wow, 217 AC for full wave.
The amps are at 1.6.
Holy cow, dude. Okay. Good eye, bro. Interesting. Interesting.
Bro.
Yeah.
2.7.
There we go. I got really into that. I'm sorry. It's okay. Good eye. Good eye. I wanted to go too high. All right. So, what are we doing? can change out the Litz coil for this coil. And put the Litz coil on top as the generator, if you follow me. Put that right there in the corona.
Thanks, Pete. Appreciate that.
Thank you. All right.
Yeah, the switches. I like the handmade switches a lot. All right, man.
What's up?
I don't know.
It's supposed to do that.
All right.
Calm yourself. Look at how well the amp draw is.
All right. Just.
We're not getting good, generation with the Litz wire coil. It's not, it works better as the other way. So. This is a 13,000 turn 32 gauge coil. Yeah, there you go. This one generates some electricity, man. It's pretty cool. That's 90, but I think the Litz. Nice. It's 180. It's awesome. It's freaking awesome. 180 volts of AC electricity is coming off of this coil at 12 volts in, and that's 3.4 milliamps. That is like less than 10 milliamps. That's awesome. That's 404 hertz sine wave. It's just the coil stacked on top of a coil, man. It's awesome. That's awesome. I can't say it enough, man. I mean, it's simple, but it's great. All right. So, what are we looking at?
Well, I'm frazzled and shocked, so I shouldn't be doing experiments like that.
Yeah, it's all right, man. You gotta shake it off, though. We're done. I think we're gonna be. Well, what should we do? You want to continue? We can stop. That's all right. But the quick explanation is that when the circuit in the transistor is closed, which we can control the rate and the rhythm, like the rhythm and what it happens at, so we can control the wave through the signal generator to trip the transistor's base and generate, as if a magnet was passing and triggering on the pulse motor. Except we get a lot more control with the signal generator. So this coil generated 180 volts of AC electricity off of 12 DC volts we put in this coil down here. Right, we're going to do green paper. And iron filings. Okay. Take this down. Now, I want to have something, that even would work. I want it to be like flat, so I'm going to put something under it. Zero out. Start at 1. Oh yeah, that's right. My bad. I've got to turn it on first. Okay. Okay is what it's called, the button. Look at that. That's amazing. I bet that'll show up on the iron filing test pretty good too.
Oh, yeah.
That's 3 hertz right there, man. That's pretty quick. The ball, the sphere that I had out here earlier, it'll spin really good with that at that speed. 7 hertz, it'll start spinning good. And then you can inch it up, you know. But that's awesome. 12 volts in. Green paper test.
Nice. It's like a heartbeat pulse.
Heck yeah. All right. Oh. No, I'm gonna put this under here too. Bought it from the wrong side. There we go. That's awesome. That is real. So cool. But notice how it's only happening in the middle and then on one side, really. Maybe even like a quarter, like just up here. And that clicking noise is the core, and the big coil is being attracted to and lifting up, and then falling down, lifting up, falling down.
Yeah, it's like art.
Yeah. Pretty sweet.
That was sweet. That's it. We got a good comment on that one. That's neat. Experiment.
Let's hook up the Litz coil real quick and see what time we got.
No, it's for you.
Yeah, I definitely want to see that. Like, but we won't do it at 12. We'll do it at like 3. See if we need more than that.
Yeah. If it needs like a special connector or something. No, I think it works.
Well, I mean, if you want it to be crisp, you need like a soldered connection, maybe, or a special connector for sure. There's 100 wires there. So, but this is good. This will work. Whoops, and it won't have the core effect. This one does. But we're not going for that. We're going for angel dust, or this stuff, the iron powder. My bad. that's not working, is it, guys?
Mm-mm.
I was thinking about turning it up, but it's so high already. One thing I might do to make it better is remove this glue. But it should, you know, have a signal strength. No. Well, that's weird because it's already hooked up, so we're just going to move it over here. I'm wondering if I need to turn up the hertz like to kilohertz. It's going down. Oh, yeah, this is right. Amp draw is going down and the volts are going up. Oh no, there we go. Oh, they're going down again. Let's see. Nope, there's like no magnetic field on that, and it's still generating energy. Like a lot. So let's go.
What's up? I walked for like 2 miles, so I probably just smell like sweat now.
Where'd you go walking?
Pond.
Nice. I gotta get out to the pond. Yes. And then there's a crane out there. A white crane. Yeah.
You get the blue heron.
Oh, I
The tall, yeah, it's a nice bird.
I've seen it before, but I didn't see it today.
Wow, okay, 221 AC volts right here. Let's see if we get any response from.
Here, Brumpies.
I'll be back.
Because it's not going to do it like that. It's not for that. But this is a lot of voltage we're getting off of the little coil. $220. It's awesome. 3 volts in. 220 AC volts out. There's no math there. We are drawing, 800 milliamps, but I don't even think with the 800 milliamps it's even close. You know? But that's awesome. Here, since it's AC, I did say we were going to do a oscilloscope reading. Oh, look at that. And each one of those spikes looks like it's 600 volts or so. That's freaking crazy amazing. He backed away. He's like, I'm backing up. Here, let's break it down to. Wow. Bro, check that out. Man, look at that oscilloscope reading, man. That is beautiful. At 426 hertz for the 12,000 turn coil right there. That's freaking awesome, and that's a beautiful sine wave right there. Beautiful. I guess that's because it's coming from a signal generator and reading such crisp reading. That it is nice. Well, we are getting a little bit of feedback from nice from the big coil. It's actually doing something.
Yeah, I see that.
Or the core is doing something, I should say. It's awesome. That's freaking cool. Yeah. All right. At 3 volts in. That's amazing. I can't, like, that's so cool. Dude, that Litz wire is awesome. Power, I don't even know what to call it, the heart of the motor.
What's up, Gig Attack?
What's up? What's up?
Nice catch.
Thank you. Thank you. Thank you. Alright, I do need the paper. So just that little spot in the middle, man. That's awesome. It looks like it's a null zone, doesn't it? There's no like bright magnetic field. It's just dark. Pretty awesome.
Thank you for the likes.
All right. Well, thank you very much, ladies and gentlemen. I'm gonna call it for today. And maybe I'll be on later tonight. Let's see what happens. All right. So have a good day. Peace out. I'll get back to you later. Bye now.